Hello friends, this is part 4 in a series of tutorials about Chromia and Rell. The concept of a player is central to all games. In this episode we will create a player. In the previous part we learned that an entity is just a database table, and in this episode we will learn that an operation is just a REST endpoint accessible from the internet. The only difference from a normal app is that the data sent to the operation must be signed by the client. I opened the operations Rell file, and apparently we don't have a create player method. I type Ctrl L and open the chat, and I describe what I need. Just to be certain, I'm pasting the player entity code into the chat too. Here is the generated code. Require is a built-in function that must be true, or the operation will abort. Create is the same as insert into from SQL. But Cursor forgot to verify that the name argument is indeed unique. We will now use Rell's select syntax. Yes, this will look strange the first time, but it actually makes sense. At just means that we are fetching data from an entity. Question mark means that we might get 0 or 1 results. And .name equals name is what we would usually put in the where clause, but remember the double equals. In the documentation we see that there are 4 different ways we can use the at character. And the symbol that comes after at signals how many rows we expect to find. Star is perhaps the most common, where we allow any number. Also, we don't want the signer's pub key to already exist in the player entity. We can use OP context to find information about the current transaction and the blockchain. The getSigners method looks at all the signatures on the current transaction and fetches the public keys. In our case, there will be only one signature, so we can get the position 0 in this list. Finally, we look for this pub key in the player entity. Let's look at the OP context in the documentation. You find it under namespaces. Another useful method is the isSigner method. It checks if the current transaction was signed by the given public key. That's useful when only the owner of something is allowed to modify it, since in crypto we use the pub key to determine ownership. Cursor tried to use OP context to set signer, but didn't get it right. We use our signer variable instead. Let's create some queries. The first, getPlayers, is very simple. It will just fetch all players. The next is getPlayerNames, where we fetch all players but only return the names. In getPlayerByName, we send the name and return the player that corresponds to that name. Both queries and operations can be called via the REST API, but the difference is that a query has a return value, while an operation can update the entities. That's it. I think we have enough code to be able to run a simple program from the CHR tool. See you in the next episode.